Today's lesson we'll be talking about section 5.3c, trigonometric graphs, where we'll graph tangent and cotangent curves. Now the functions for tangent and cotangent, they look very similar to the setup of sine and cosine, except obviously they're different trig functions, so they're going to create a different picture. Now here, one property that we need to talk about before we move forward is the period for tangent and cotangent curves. They're a little different than the sine and cosine. Remember, sine and cosine were a period of 2 pi. Tangent and cotangent are actually shrunk, and they're a distance of pi, normally. So their period is mapped out by pi divided by the k value that is multiplied to the x. Okay, so and down here, all these are stating is that if you added pi to the x value, or for either tangent or cotangent, you would get the same function that you had originally, so the same y values, whether you're the phase shift. So it's basically saying if you shift your trig function or have a phase shift of pi in either direction, you will get the same picture for your y values for tangent and cotangent. Okay? So let's graph some. Now we're going to graph both, and like we did in class for sine and cosine. So tangent, now we're going to plug, or for tangent and cotangent, we're going to plug in all the values in between 0 and pi, and then we'll graph those. So for tangent, if I plug in 0, okay, tangent at 0 is your y divided by your x, okay, so 0 divided by 1 will get you 0. Okay, if I take pi over 6, then that's going to be 1/2 divided by square root of 3 over 2 at pi over 6, or 30 degrees. Then that gets you square root of 3 over 3, or 1 over square root of 3, whichever of those you would like. Okay. For pi over 4, if I plug in that one, then I get square root of 2 over square root of 2, which is 1. For pi over 3, it's the opposite of what pi over 6 was, so it's square root of 3 over 2 divided by 1/2, so it leaves you with square root of 3. At pi over 2, remember that sine is 0, or sorry, sine is 1 at that point, and cosine is 0 at that point. So that means that you're taking 1 divided by 0, and you can't do that. So we say that's undefined at pi over 2. And then at 2 pi over 3, we plug in, so now we're kind of going backwards. So you have negative square root of 3 over 2 divided by 1/2. So then, or sorry, negative 1/2, and square root of 3 over 2 is positive. But you still get a negative square root of 3. At 3 pi over 4, your cosine is negative now, so square root of 2 over 2 divided by negative square root of 2 over 2 gets you negative 1. And 5 pi over 6, you get 1/2 divided by negative square root of 3 over 2. So then flipping that up gets you a negative 1 square root of 3. If you rationalized it, it would be negative square root of 3 over 3. And at pi, you get the sine value of 0 over cosine value of 1, so that gives you 0. Okay? Now let's do the same thing for our cotangent. So here you're going to see the values are very similar, because tangent and cotangent are reciprocals of each other, so they should share ratios with one another, just not in the same order. So at 0 for cotangent, now you're taking the x divided by the y, or the cosine divided by the sine. So here you have 1 divided by 0. So for that point, at 0, cotangent's undefined. At pi over 6, now you have square root of 3 over 2 divided by 1/2. That gets you square root of 3. Okay. At pi over 4, So you get square root of 2 over 2 divided by square root of 2 over 2. So you get a positive 1. At pi over 3, now you have your 1/2 divided by square root of 3 over 2. So if you flip that up, remember that's like 1 over square root of 3. Or if you rationalize, it'd be square root of 3 over 3. Remember, you don't have to rationalize, it's just my own habit that I rationalize it normally. Pi over 2, here, instead of it being undefined like tangent, now you have 0 divided by 1, so that should get you 0. Okay? And then for 2 pi over 3, you have negative 1/2 divided by square root of 3 over 2. So it's just the opposite of what pi over 3 was. So negative square root of 3 over 3. It's the opposite sign. Okay. At 3 pi over 4, here you also have a negative square root of 3 over 2, or sorry, negative square root of 2 over 2 divided by square root of 2 over 2. That gets you negative 1. Okay. And then at at 5 pi over 6, you get negative square root of 3 over 2 divided by 1/2. Flip that up. That gives you negative square root of 3. Okay. And then at pi, now you're back to having negative 1 divided by 0. So that gives you an undefined. Okay. So here, if we graph these, let's take a peek at what they look like. So let's go with the tangent first. Okay, so at 0, your y value is 0. At pi over 6, we said that it was square root of 3 over 2, or sorry, not square root of 3 over 2, square root of 3 over 3, so that's about 0.57. So you could probably put it just a little bit above half. Then if I do pi over 4, that gets me 1. Okay, and maybe this first point's not that good. There we go. Then at pi over 3, you have square root of 3, so that's 1.73, so then that's going to be pretty close to 2. Okay, and then at pi over 2, it looks like my values are wrong. Let me readjust here. There we go. I just had my pi over 6 at the wrong spot, sorry. So let's readjust those. So pi 1 and there we go. So that makes a little bit more sense. I have my increments, if you didn't notice, in pi over 12s. Okay, so that's how this one right here is going to be at pi over 4. The next one's pi over 3. So I'll just use in fractions to erase my thing. Okay, now at pi over 2, now I've got an undefined line. So I can write that vertically. Okay. And then at 2 pi over 3, I have negative square root of 3, so that would be negative 1.73. It'll be right about there. Oh, wrong spot again. Oh. Keeps deleting that 1 point over there. Okay. And then at 3 pi over 4, we're 1. And then at 5 pi over 6, it's square root of 3 over 3, which is going to be about negative 0.58. And then at pi, it's 0. Okay, so 1 period, your function would look like this. Now, the asymptote helps you out is that all your lines, like vertical asymptotes, you can't cross a vertical asymptote. Okay, so they must only approach vertical asymptotes. So since your lines are kind of, your dots are heading towards one, that means as you get closer, you're going to get closer to it but never touch, so you're going to keep going up as well. And then on the right side of that asymptote at pi over 2, it's coming from the bottom and going up to pi, so it should kind of curve down like I've drawn. Okay. Now those are all the points that we have so far. You could continue this if you wanted to, so because it's a repeating fashion just like sine is. So if I continued, 7 pi over 6 would be right here. 5 pi over 4 would be right there. 4 pi over 3 would be right about there. You would have an asymptote at 3 pi over 2, so we could continue this line. And then at 5 pi over 3, you'd have a point here. At 7 pi over 4, you'd have a point here. At 11 pi over 6, you'd have a point here. And then at 2 pi, you'd have a point at 0. Okay? So then that's kind of what your picture would look like, and it would repeat that over and over and over again. Okay? So now let's do our cotangent. So here, 0 is an undefined line. Okay? So is it at pi, so we can kind of put those in. Alright, so then now at pi over 6, it's square root of 3. So then that means that you're about 1.73. And then at pi over 4, it's 1. Oop, I have my values at the wrong spot again. Okay, and then at pi over 3, it's square root of 3 over 3, so that was about half. And then at pi over 2, it's 0. And then at 2 pi over 3, it's about negative half. And then at 3 pi over 4, it's negative 1. And then at 5 pi over 6, it's negative square root of 3, so that's about negative 1.7. Okay, so then your graph for cotangent kind of looks like that. Okay, so they intersect each other at the values of pi over 4 and 3 pi over 4 because they match at those because it's the same kind of ratio. But then everywhere else is kind of a little bit like a reciprocal. If you continue this graph, there would be another undefined line at 2 pi, and then you'd have the following picture that you could tack on. So oh, sorry about that. Okay, so there would be our picture right there. Okay. Now make sure we'll start applying period and all the other stuff with tangent and cotangent as well, but this is just the basic of what tangent and cotangent should look like when you graph. Okay? Have fun.